welcome back to properties of indices. So this lesson 2 on indices that we started. So I've given a link in the description section for the lesson 1 and the indices, so you can check and watch so that I can build your understanding from there up to this point. So in this video we are looking at the properties of indices. So if you are new here, please kindly consider by subscribing, liking and sharing our videos so we can reach and serve everybody with challenges in mathematics. Thank you once again. So let's let's continue with our indices that we are actually talking about. So today we are looking at properties of what? Indices. So as we said with the previous video, we discussed the meaning of indices, then we talk about the laws of indices. All of them are in the description section of this lesson, so check it. The link is there so that I can watch from there. All right, so we are looking at the properties of indices in this video. All right, so the first property that we are looking at is property 1. We are looking at this property, so I'm going to use P1 to represent the property we are actually looking at. All right, so property 1, we are saying that if I have any number to the power of 0, it should be equal to what? 1. Any number raised to the power 0 should be equal to 1. So the emphasis here is that any non-zero number raised to the power 0 is equal to what? 1. Any non-zero number raised to the power 0, raised to the power 0, raised to the power 0 is equal to 1, equal to what? 1. So let's take note of that. In non-zero number, so if the item is non-zero number, then we can say that it should be equal to 1. So for example, if I have h raised to the power 0 is equal to what? 1. If I have, let's say, y raised to the power 0 is equal to what? 1. So any non-zero, if I have, let's say, 100 raised to the power 0, it should be equal to what? 1. So let's take note of the non-zero aspect that we are talking about. So that's property 1. Then property 2. P2. Here's what we are saying. The property 2, if I have a different base, all right, which the two are multiplying together, let's say base A and base B, and they are multiplying each other, and they are all having an exponent of what? N. This property is telling me that I can break this one to 2 by saying that the N is gonna take the A, then N is going to take what? The B at the same time. So it becomes what? A N multiplied by what? B N, and after they're going to get what? A N B N. So that is the property 2. Anytime you have any item of this nature and you're having all of them having an exponent of equal, just take the power of that exponent for the base. Okay, and that's what we have done here. So for example, if I have 2 multiplied by 4, okay, and let's say they all raised to the power, let's say 2, I can write this by saying this 2 raised to the power 2 multiplied by 4 raised to the power 2, and then I'm going to get what? 2 raised to the power, which is what? 4, all right, multiplied by 4 raised to the power, which is what? 16. Then my result will be what? 48. Oh, sorry. Yeah, sorry, 64. 16 by 2 even is 32, right? So twice is going to give you what? 64. Sure, 64. This is what I'm saying, 64, right? Or better still, you can still apply your rule, the general rule. The number of times the base is multiplying itself together, that's what index tells us telling us. So that is a property 2. Then property 3. Property 3 also saying that now if I have, let's say, a raised to the power negative n, I can rewrite this in the form of what? 1 over what? A raised to the power what? N. That's all I can do. This is an inverse form. So if I'm writing in that horizontal way, I'm going to have the a, but remember here it is positive, so once it joins, so it becomes in that horizontal manner, the n will change to what? Negative n. Okay, so that is the property 3 aspect that he's talking about. So for example, if I have, so here too, the emphasis here is saying that provided a is not equal to what? 0. That is the emphasis I need to get it right. Provided a is not equal to, that is, any number raised to a negative index is equal to the reciprocal of the number raised to the same but positive index. That's what we are saying, the reciprocal form. Alright, so here if I raise to the negative, it's just a reciprocal. So I'll find the reciprocal of this I'm getting. This is the reciprocal form, which is a raised to the power n. I hope that is clear. Alright, so here for example, if I have let's say 2 raised to the power negative 1, I can say that this one is equal to 1 divided by 2 raised to the power 1 is the same thing as what? 1 over 2. Again, if I have, let's say, x to the power of negative y, I can say that this is equal to 1 over what? X raised to the power y. This is what we are saying, x raised to the power what? Y. So that's property what? 3 aspect that we are talking about. Alright, so let's move on to property what? 4. But before we move on to the property 4, okay, before we move on to property 4, we can also have the opposite of the property 3 here. So now here it was a raised to the power negative n, but in the case where they have 1 over a raised to the power negative n, it's the same approach. So if here it was negative n, and you're writing them in the form of horizontal section form, that's what I used to call it. You are going to, this one is going to be changed. Want you have everything to be what? The numerator, which is the bigger part of it. So this negative will change to what? So here becomes what? A raised to the power what? N, instead of the negative. Yeah, you take a calculator and test for it on yourself. You understand the reason why we are having a to the power. Let's say if I have, for example, if I have 1 raised to the power 2 raised to the power 1 over 2 raised to the power what? Negative 1. It's the same thing as what 2. With the calculator, you are good to go. So let's take note of that. So property 4. Property 4. So property 4 is also saying that now if I have 2 base where they are dividing n, they are all having an exponent which is raised to the power n. It's more similar to property 2, but just that property 2 was in that horizontal manner form. Here they were multiplying. That's why we actually took the exponents for both bases. Okay, but here too they are dividing. A is being divided by what? B. So the same approach, you are going to take a for n and you take b, the same thing for n. All right, so that's how the approach is gonna be. So here the emphasis also is saying that providing b is not equal to what? 0. So let's take note that providing b is not equal to what? 0. We can rely on this approach, and we can say that this is also equal to this. So for example, if I have say 2 over 3 all raised to the power 2, I can say that here it is 2 raised to the power 2 divided by 3 raised to the power 2. Okay, then it becomes 4 divided by what? 9, and that will be my answer for the day. Alright, so that is property 4 for you. Then with property 5, here's how property 5 was saying. Property 5, P5. Property 5 was saying that it's just an opposite to this. If I have A over B and all is having an exponent of negative n. Okay, well, all that you need to do is do the same approach here. The negative n will take the a, and negative n going to take what? The b. Or better still, find the reciprocal of what? The fraction here, and immediately you find the reciprocal of this fraction, this negative change to what? Positive. Or better still, take the negative n on both what? Bases. You take a, you take raised to the power negative what? N, or you take an exponent of negative n, and b, you take an exponent of negative what? N. Then you apply your third law. You apply your what? Your property, sorry, your property 3. This property 3. Then you are good to go. Or better still, find the reciprocal of the fraction. So here, if I find the reciprocal of the fraction, it becomes what? B over a. And immediately I find the reciprocal of the fraction, this negative n change becomes what? Positive n. Therefore I can stick to my property what? 4. We're saying that it becomes what? B raised to the power n, then a raised to the power what? N. Or with property 3, where you apply, with property 4, where you apply the negative exponent n on both what? Bases. And after that, you think of your property 3, which you'll be having in this form. Then you change them to this form. Or if you don't want that approach, you can find the reciprocal. Anytime you have a negative what? Exponent, and in terms of what? Fraction, or two bases which are in fraction, or which are in which one is dividing the other, you just find the reciprocal, and then the exponent will change to positive. Then you apply your property 4, and we are good to go. So let's take an example. Let's say example 1. If I have 2 over 3 all to the power negative 4, let's say 2. So here, all that I will do is to find the reciprocal for the 2. So it becomes what? 3 over 2. Okay. Immediately I change it to become 3 over 2. This negative 2 change becomes what? Positive 2. Okay. So then I can apply my fourth property, which is saying that I need to square the 2. Sorry, I need to square the 3. Then I need to square the 2. Same. So I don't really going to get what? 9. Then divided by what? 4. Then I'm good to go. So that is property 5 for you. So let's move on. I hope everything is clear. These properties are very easy to understand. So if you have any question, comment below the chat section, then I can assist you on any question that you have. Thank you. So let's look at property 6. So property 6 is also saying that now if I have, let's say, a to the power of what? Half, I can rewrite these as what? A square root. Remember, square root is equal to what? Half. Per our said rules, we are saying that anytime you have half is equal to the square root. Alright? But if I have a raised to the power 1 over 3, we can say that this one is equal to a square root, but we are saying that this one is equal to the cube root. So you're going to have what? Cube root is small 3 at top, then raised to the power what? A. Alright? If I have a raised to the power 1 over 4, then we are saying that this one is what? The fourth root of what? A. And this is what the property says is actually saying. Alright? So let's take note of that. So in general, if I have a raised to the power 1 over n, then we can say that here it is the nth root of what? A. I hope that is clear. That's what we're actually saying. The nth root of what? A. So that is basically the approach that we want to understand. So for example, if I have if I have, let's say, 16 to the power of what? Half, I can rewrite by saying that here is square root of what? 16, and square root of 16 is gonna give me what? 4. Let's say I have 81 raised to the power 3, and I can say that this one is the cube root of what? 81. Okay, so if I have cube root of 81, then we are saying that cube root of 81 is equivalent to true or false. All I need to do is just break this one down. How many times can you get from 3? We can say that 3 raised to the power what? 3 3 raised to the power 4 will get me what? Yeah, let's pay attention here. I was talking about h rather, which is h raised to the power what? 1 over 3 and not necessarily 81. Alright, so that's why I've written here what 2. So here I raised to the 2 to the power 3, then the 3 will cancel the end fruits. So I'm going to get what? 2. The reason why I had 2 here was that it is 2 raised to the power 3. Remember, here is what? 1/3, so multiply by 1 over 3, where we apply your property 2. If you can remember, I said property 2, your power law, you multiply the exponent, then you are good to go. So here the 3 will cancel that, so it becomes what? 2. That's why we had a 2. So let's take note of that. Alright, so that is generally the properties that we need to know under indices. Okay, so this is where we bring an end to lesson 2 under indices. So in lesson 3, we'll be looking at what? Various questions and how we can apply the laws and properties we have learned so far to deal with most of the questions that indices houses, so that we can build our understanding better and move on to other aspects. So thank you once again for watching. It's been a pleasure coming your way to assist you. So if you have any question, kindly comment below so that I can assist you and guide you and help you to answer most of the questions that you find challenging and difficult. And if this video was helpful to you, kindly consider by giving us your liking, sharing, and commenting, and anything that you want to do to help this channel to grow and grow very successfully. Thank you once again. I'll come your way with lesson 3, where we solve questions under indices. Thank you and see you in the next lesson. Bye bye.